In this video, we're going to solve several word problems that require a linear equation, okay? Either one or two variables, but nothing with an exponent greater than 1. Our first example says that Sarah paid $15.95 to become a member at a gym, and she also paid a fee every month. Her total cost for a year was $735.95. If she went to the gym a total of 214 days, how much was the monthly fee? So our unknown variable is the monthly fee, so let x equal the monthly fee. And let's figure out how many times she had to pay that fee. Well, it said she had to pay that fee every month, right? It's a monthly fee. So over the full year, she paid it 12 times. So 12 times x is the amount she paid in monthly fees over the 12 months, or 1 year. She also had to pay an initial joining cost of $15.95. So far, this is what she had to pay for the gym for the year. There's this other piece of information here that says if she went to the gym a total of 214 days. Well, there's nothing about an additional fee for going on a day or not going on a day. The fee is just every month. So that piece of information is actually there to mislead us. This 12 times the monthly fee plus the $15.95 she paid originally is how much she paid for the whole year. Well, we know that that's equal to her total cost for the year, $735.95. So from here, we can solve this for x, that monthly fee. We're going to subtract $15.95 from both sides. On the left, that'll cancel out, and on the right, these 95s will cancel out, so 735 minus 15 gets us $720. Dividing by 12 on both sides will get us the monthly fee, because the 12s on the left will cancel. So x equals $60. Since we were asked a question with a word problem, we're going to put our answer as a full sentence. So her monthly fee was $60. Our next question says, of two consecutive integers, twice the smaller is 4 less than the greater. Find the integers. So in this case, we have two unknowns. We have the smaller integer, we'll call that one x, and we have the greater integer, or the larger integer, y. So x is the smaller integer, and y is the bigger, or the greater integer. Okay, and our information says twice the smaller. 2 times the smaller is, okay, is our equal sign, is 4 less than the greater. So we take the greater and we take 4 less than it. So twice the smaller is 4 less than the greater. Now the other piece of information they give us is that these are consecutive integers. That means that one comes right after the other. For example, 2 and 3 are consecutive integers. 7 and 8 are consecutive integers. 7 and 9, however, are not consecutive integers. 9 and 21 are not consecutive integers, but 20 and 21 are consecutive integers. Essentially, the second one is one bigger than the one before it. So we know that the larger integer, y, is one more than x. So we know that y is just one more than x. Knowing these two things, these two equations, we can use substitution to solve for x. So in the original equation we came up with, where 2x equals y minus 4, now in place of y, I'm going to put the fact that I know that y is just one more than x. So we have 2x equals x plus 1 minus 4. Well, plus 1 minus 4 is the same as minus 3. We want to put all the x's on the same side. On the right-hand side, they cancel. On the left, we had 2x minus x, so we just have 1x left, and that comes out to negative 3. If x equals negative 3, remember that y is just one more than that, which means that y must equal negative 2. Let's check that back in our original equation. We originally said that 2 times x, so 2 times negative 3, should be equal to y, negative 2, minus 4. Well, 2 times negative 3 is negative 6, and negative 2 minus 4 is negative 6. So this works, and it's true that negative 3, negative 2 are consecutive integers. Right down here is negative 4, up here is negative 1, etc., okay, in both directions. So yes, these are consecutive integers. So the integers are negative 3 and negative 2. Our third problem says, on September 1st, Paul bought a student discount card for the bus. The card costs $7 and allows him to buy a daily bus passes for $1.50 instead of $2. By the end of September, Paul spent a total of $29.50 on bus transportation. How many daily bus passes did Paul buy? So the first thing it says that he bought is this student discount card, and it said that that card cost $7. So part of what he spent in the month of September was that $7. Then he bought a certain number of bus passes. That's our unknown. And on each of those bus passes, he spent $1.50. So in addition to this 7, so we're going to use a plus, in addition to that 7, he spent $1.50 times X, times the number of bus passes he bought. And that all came out to a total of $29.50 for the month of September. There is also this number 2 for $2 in here, but notice that that just means that he had to spend $1.50 on each bus ticket instead of that $2. So that $2 doesn't factor into the money that he spent. So let's solve this for x. Subtract 7 from both sides. On the left, that cancels. On the right, we get $22.50 left after we take 7 from $29.50. So we have $1.50 times x equals $22.50. We're going to divide both sides by $1.50, which tells us that x equals 15. So Paul bought 15 daily bus passes. Problem 4 says, at the end of the day, Janelle had $10 more than 3 times the money she had in the morning. She now has $160. How much did she have in the morning? So our unknown number x is how much money she had in the morning. It says that Janelle has 10 more than, so that's plus 10, 10 more than something, 10 more than 3 times the money she had in the morning. So 3 times the money she had in the morning is 3x because we defined the money she had in the morning as our variable x. So 10 more than 3 times the money she had in the morning, and she now has $160. So let's solve this for x. We're going to subtract 10 from both sides. The 10's on the left will cancel. We'll get that 3x equals 150. Dividing by 3 on both sides, that cancels on the left. X must equal 50. Janelle had $50 this morning. Problem 5 says, find a rectangle so that its height is 1/5 of its width and its perimeter is 120. And there's a small typo here that should say so that its height is 1/5 of its width. Okay, so we'll have h represent the height and w represent the width. And we know 2 pieces of information about that. We want the height to be 1/5 of its width. Remember that when we say a fraction of something, that really means that we're multiplying that fraction by that quantity. So the height is 1/5 of the width. Also know that its perimeter is going to be 120. Well, we're dealing with a rectangle, okay? And a rectangle, right, has the height here, the width, and the width. And so its perimeter, capital P, is h plus w plus w, which we can write as 2h plus 2w. And we know that the perimeter needs to be 120. So another equation we have is that 120 equals 2h plus 2w. Now we can use substitution like we did in a previous problem to get one equation in one variable. So I'm going to take h is 1/5 of the width, and I'm going to plug it in for h in this perimeter equation. So 120 equals 2 times the height, which I know is 1/5 of the width, plus 2 times the width. So 120 equals 2 times 1/5, so 2/5 w plus 2w. So I need to combine 2/5 w and 2w. Well, that means I'm going to need to add 2/5 and 2. To add a fraction to a whole number, or to add 2 fractions together, I need to have a common denominator. So I need to have something here with a denominator of 5 that is equivalent to the whole number 2. We can write 10 in the numerator there because 10/5 is equal to 2. Essentially, I've replaced 2 with 10/5. It's the same number, but it looks different, and it's now in a format where I can add it to 2/5. So our denominator is still 5, but our numerator becomes 12, okay? 2/5 plus 10/5, there are now 12 of them. So 120 equals 12/5 w, and to clear a fraction, we want to multiply by the reciprocal of that fraction on both sides of the equation. So if we have 120 equals 12/5 W, we want to multiply both sides by 5/12. On the right, 12/5 times 5/12 is 1, so those cancel out, and we're left with just W. 5/12 of 120. Well, we can do a little bit of simplification here before we do the multiplication. We're going to get 5 times 120 in the numerator and 12 times 1 in the denominator. I can recognize right now, though, that 120 divided by 12 is 10. So we can simplify this already to just 5 times 10, which is 50. So we've determined that the width is 50, and since the height is 1/5 of that, 1/5 of 50 is 10. So 10 is our height. Let's check our perimeter then. If the height is 10 and the width is 50, let's see, 10 plus 50 is 60, 60 plus another 10 is 70, and 70 plus 50, yes, that gets us a perimeter of 120. So this is correct. The width is 50 and the height is 10. Our last problem says, Louisa, Lois, and Len worked together weeding a 360 square foot garden. Louisa did 3 times as much weeding as Lois, and Len did twice as much weeding as Lois. How many square feet did each one weed? So we want to know how much Louisa weeded, how much Lois weeded, and how much Len weeded. Well, they tell us that Louisa did 3 times as much weeding as Lois. So let's have Lois be X amount of weeding, X square feet. And then Louisa is going to be 3 times that amount. She did 3 times as much as Lois. And it says that Len did twice as much as Lois. So he's going to be defined as 2 times X, twice as much as the square footage of weeding that Lois did. Now we know that together they finished the entire 360 square foot garden. So that must mean that the portion that Louisa contributed 3 times as much as Lois, the portion that Lois contributed, X, and the portion that Len contributed, 2X, twice as much as Lois, must all add up to 360 square feet. 3X plus 1X plus 2X comes out to 6X. So 6X equals 360. Dividing by 6 on both sides, we get that X equals 60, and our units on that are square feet. That means that Louisa weeded 60 square feet, Len weeded 120 square feet, twice as much as Lois, and Louisa did 3 times as much as Lois, which is 180 square feet. Now let's double check that to make sure it adds up to 360. 180 plus 60 is 240, and then 240 plus another 120 for the portion that Len did does add up to 360. Good. So Louisa weeded 180 square feet, Lois weeded 60 square feet, and Len weeded 120 square feet.